Today we're going to be solving quadratics using another method called completing the square. I'm not exactly the biggest fan of this particular method. I would much rather prefer to factor a quadratic or use the quadratic formula, but nevertheless, I'm going to show you yet another method that you can use to solve a quadratic. And remember, when we solve a quadratic, we're finding those x-intercepts. Where does the graph cross the x-axis? Where are our y values? 0. So to solve by completing the square, we will manipulate the equation. So we're going to change it around to make it look something like this. And as you can see in this equation, on the left side of the equal sign, I have an expression in parentheses, and that entire expression is raised to the power of 2. There's my perfect square. Equals, and then I have a constant on the right side of the equal sign. So remember, x minus 4 squared, that's just this, x minus 4 times x minus 4. And that's my perfect square. So the steps that we're going to take to solve a quadratic by completing the square, the first thing we're going to do is move the constant to the right side of the equation. So your equation, x squared plus bx, you're going to move that constant to the right side so that it's on the right side of the equal sign. And then you're going to add b over 2 squared to both sides of the equal sign. Because remember, what we do to one side, we have to do to the other so that our equation stays balanced. So we're going to add this right here, b, and we're going to divide it by 2, and then we're going to square it. And that's going to help us create that perfect square. Then we're going to factor the perfect square trinomial, and then we'll take the square root of both sides, set up two equations, and solve. So let's put this into practice. Looking at our first example, and here is a type of example when a is 1. So I don't have the coefficient, the leading coefficient is just 1. Okay, so when a is 1. So the first thing we're going to do is move our constant to the right side. So how do I do that? I do this, right? I'm going to add 40 to both sides. So now I'm left with x squared plus 6x equals 40. And then step 2 says I'm going to add b over 2 squared to both sides. What is b over 2 squared? Well, b is 6. So 6 divided by 2, and then we're going to square it. 6 divided by 2 is 3. 3 squared is 9. So here's how I like to write this. I'm going to add 9 to both sides of my equal sign. So x squared plus 6x, and then I'm going to add b over 2 squared to the left side, and I'm going to add b over 2 squared to the right side. So what is that? It's 9. So now, as you can see in our quadratic right here, x squared plus 6x plus 9, that's a perfect square. What numbers multiply to 9 and add to get 6? 3 and 3, right? So that would be x plus 3 times x plus 3, which is just x plus 3 squared. So I'm going to write that over here. X plus 3 squared equals 40 plus 9 is 49. And now the last step, so we factored it, the very last step, we're going to take the square root of both sides. So how do I get rid of this raised to the power of 2? I take the square root of it. What I do to one side, I have to do to the other. So essentially what this does is that square root gets rid of that exponent, and I'm left with just x plus 3 equals positive or negative square root of 49. Whenever I'm undoing an equation, you like my fancy terminology, undoing an equation, and I take the square root of both sides, I'm always going to be left with positive or positive and negative in this case. So now let's go ahead and rewrite that again. X plus 3 equals positive, negative, square root of 49 is 7. So now we're going to set up two equations. We have two solutions here. The first equation, and I'm going to write this way up here, is if I'm solving for the value of x, I'm going to subtract 3 from both sides, right? So my first equation is positive 7 minus 3, which is 4, and negative 7 minus 3, which is negative 10. And those are my solutions. And then remember, I can write them out as a list, negative 10 and positive 4. So let's move on to our second example. So the second example, it's just another example like the first one. So I'm going to go through it a little bit more quickly. So the first thing that we're going to do is move our constant to the right side. So I'm going to be left with x squared plus 10x equals negative 9. And then I'm going to add b over 2 squared to both sides of the equal sign. So I'm going to write it out like this. I'm going to add something there, and I'm going to add something there. What am I going to add? B over 2 squared. What is b? It's 10. 10 over 2 squared. 10 divided by 2 is 5. 5 squared is 25. So 25 is what I'm going to be adding to both sides of the equal sign. So now we need to factor this perfect square trinomial. How does it factor? What's the number, the same number, that when it multiplies by itself I get 25, when I add it to itself I get 10? It's 5. So x plus 5 squared equals negative 9 plus 25, 16. Okay, next step. How do I undo that square? I take the square root of both sides. So I'm left with x plus 5 equals positive or negative square root of 16. And again, I'm going to rewrite that because the square root of 16 is 4. So x plus 5 equals positive or negative 4. So now if I'm solving for x, I'm going to subtract 5 from both sides. Okay, but I have two solutions. I have 4 minus 5 and negative 4 minus 5. So I need to set up those two equations. Positive 4 minus 5, which is negative 1, and negative 4 minus 5, which is negative 9. Those are my solutions, so I can write them out as a list. So x equals, if you want to write that, or you can just leave it like this, negative 9, negative 1. Okay, let's move on to the next scenario. So this is an example when a is not 1. So as you can see, I have an a value that's not 1. My leading coefficient is 2 here. But I'm still going to move my constant to the right side of the equal sign. So that's what I'm going to do first. So I'm going to be left with 2x squared plus 28x equals 30. Now here's a situation where you have to do one little thing. I need to get rid of that 2. So what I need to do is to divide every term by the coefficient of the first term. So let's write that down. Divide every term by the coefficient of the first term. Coefficient of the first term, and that is just a. Okay, so we're going to divide every single term by 2. So divided by 2, divided by 2, divided by 2. And remember, if what I do to the left side, I do to the right side, my equation stays balanced. Okay, so now I'm left with x squared plus 14x equals 15. And now I'm back to where we were in examples 1 and 2. So that's what you have to do. If you have a coefficient other than 1, a leading coefficient other than 1, you divide that out of every single term, even if it's not pretty, which we'll get to in example number 4. But now we're back to where I'm going to be adding something to both sides of my equal sign. What am I going to be adding? B divided by 2 squared. So what's my new value of b? It's 14. So 14 divided by 2, and then I'm going to square it. 14 divided by 2 is 7. 7 squared is 49. So 49 is what I'm adding to both sides. So now let's factor this perfect square trinomial. What number times itself gives me 49, and when I add it to itself, I get 14. 7. So x plus 7 squared equals, what is 15 plus 49? 64. Okay, and what do I do at this point? How do I get rid of that perfect square? I take the square root of both sides. So x plus 7 equals positive or negative square root of 64. And let's go ahead and rewrite that. X plus 7 equals positive or negative. Square root of 64 is 8. So now let's set up our two equations. What are our two equations going to look like? I've got to subtract 7 from both sides. So my first equation is going to look like 8 minus 7, which is 1. And the next equation is negative 8 minus 7, which is negative 15. So these are my two solutions, negative 15 and 1. Those are my solutions. So let's move on to number 4. In example number 4, I'm still going to be moving that constant to the right side of the equal sign. So 2x squared minus 14x equals 5. And now, remember, I want to get rid of that leading coefficient. So what do? I'm going to divide 2 out of every single term, the left side and the right side. It's not so pretty over here, though, this time. So here's how we're going to write this. X squared minus 7x equals 5 over 2. We're just going to leave it as an improper fraction, and that's totally fine. So now we're back to where I'm adding something to both sides of my equal sign. What am I adding? I'm taking b, which is negative 7. I'm dividing it by 2, and then I'm squaring it. Instead of taking, oh goodness gracious, instead of taking negative 7, then dividing it by 2 and squaring it, what can I do? I can square the numerator and square the denominator. So negative 7 squared is 49, and 2 squared is 4. So I can actually add 49 over 4 to both sides of the equal sign. Okay, and here's where it gets a little bit crazy, and I'm actually just going to change colors here because it's just what I like to do. So now I need what number, when multiplied by itself, gives me 49 over 4, and when added to itself, I get negative 7. Well, what it's always going to be is this middle, this b value, divided by 2. So it's actually going to be x, and they're going to take the sign that's in front of the b value, right? So if it were x plus 7x, or x squared plus 7x, it would be x plus 7 over 2, but since it's x squared minus 7x, it's going to be x minus 7 over 2 squared. So if you think about it, 7 over 2 times 7 over 2 is 49 over 4. That's how I got that right there. 7 over 2, negative 7 over 2 plus negative 7 over 2 is negative 7. So equals, now here, over here, we've got some fractions with unlike denominators. So we need to make sure that when we're adding fractions, we need a common denominator, and that denominator would be 4. So I'm actually just going to rewrite that. Obviously, I don't need to change anything over here, but I multiplied 2 by 2 to get 4, so I'm going to multiply 5 by 2 to get 10. And now I can just add my numerators, and I'm going to keep my denominator. So that's 59 over 4 equals x minus 7 over 2 squared. Ooh, this is fun. I love it. So now what do? I need to take the square root of both sides. So x minus 7 over 2 equals positive or negative square root of 59 over 4. And remember, that's the same thing as x minus 7 over 2 equals positive or negative square root of 59 over square root of 4. And what is the square root of 4? It's just 2. So again, follow me on this. I'm going to rewrite it up here. X minus 7 over 2 is on the left side of the equal sign equals positive or negative square root of 59 over 2. Okay, so there's what we've got. It's ugly, but that's our answer on the right side. So to get x all by itself, let me change colors here again just because. To get x all by itself, I'm going to add 7 over 2 to both sides. And here's what that's going to look like. X equals 7 over 2 plus or minus the square root of 59 over 2. Okay, we just did a little mini review over when you're adding fractions, you need a common denominator. Do we have a common denominator? We sure do. So here's how I can combine this and simplify it. I can make it one denominator, 7 plus and minus the square root of 59. And that is what your answer would look like. Whew! That was good. Okay, let's move on to our last two examples. And I know that was a lot. That's typically really difficult if you're an Algebra 1 student. That's typically difficult if that's the first time you've seen a solution, a quadratic solution look like that. So, but let's move on because I do have another example that's like that, example number 6. So, but let's look at number 5. So this is my last set, and this is when your a value is negative. It's just like, you know, the leading coefficient isn't 1, it's -1. So we're going to have to divide that out of every term. But the first thing we're going to do is move that constant over. So equals 20. And now I can go ahead and divide every term by -1. Divide every term by -1. Okay, so I'm going to go ahead and do that. So I'm going to divide that term by -1, that term, and that term by -1. And I'm going to be left with x squared plus 8x equals -20. And now I'm at the point where I'm going to be adding something to both sides. It's got to be to both sides to create a perfect square trinomial. But what am I going to be adding to both sides? Well, I'm going to take that b value, divide it by 2, and square it. So b is 8. I'm going to divide it by 2, and I'm going to square it. 8 divided by 2 is 4. 4 squared is 16. So 16 is what we're adding to both sides of the equal sign. So now how would I factor that trinomial on the left side of my equal sign? X plus 4 squared equals -20 plus 16. Did I do that right? You know what? I totally messed up. This should be -20. When I divide it by -1, it should be +20. That should be +20 plus 16. Anybody catch that? Well, if you were in my class, you'd get a peppermint. But 20 plus 16 is 36. So now we're going to take the square root of both sides. So x plus 4 equals positive or negative square root of 36. If I simplify that, that's x plus 4 equals positive or negative 6. Now let's set up our two equations. So my two equations are 6, you know what, let's, and remember, we're going to be subtracting 4. So let's rewrite our equations up here. So one equation is positive 6 minus 4, which is 2. And the other equation is -6 minus 4, which is -10. And those are my two solutions, 2 and -10. And I write them from least to greatest. So -10 and 2. So let's move on to our last and final example. I think this is probably one of the more difficult ones. It's a lot like number 4, but let's get started. So last example. So the first step, we're going to move that constant over to the right side of the equal sign. So I'm going to rewrite this, -x squared minus 5x equals -5. And now what do I do? Divide every term by -1. So obviously everything is just going to switch. Plus 5x equals +5. And now I'm going to add something to both sides to create that perfect square trinomial. But what is it that I'm going to add? I'm going to take that b value, divide it by 2, and I'm going to square it. Okay, so the b value divided by 2 is 5 over 2, and then I'm going to square it. Remember, if I just have an improper fraction like this, what can I do? I can just square the numerator and square the denominator. So I actually get 25 over 4. So 25 over 4 is what we're going to be adding to both sides of the equal sign. And then now I'm going to factor this perfect square trinomial. And remember, Your perfect square trinomial, it's going to be x plus, because this right here is a plus sign, and then I just take that b term, which is 5, and I divide it by 2. It's always that b term cut in half, so we're just going to leave it as 5 over 2 squared equals 5 plus 25 over 4. Okay, so in order to add fractions, what do we need? We need a common denominator, so I need a denominator of 4. That is my LCD, least common. So I just rewrote that second fraction because I obviously don't need to change it, but the one on the left, I do. Remember, 5 is the same thing as 5 over 1, so I multiply my denominator times 4 to get 4. What I do to the bottom, I got to do the top, so 5 times 4 is 20. And now I can just rewrite this, but I'm going to combine my numerators. 20 plus 25 is 45. Denominator stays the same. And now, what do we do at this point? We take the square root of both sides. So again, x plus 5 over 2 equals the positive and negative square root of 45 over 4. And remember, 45 over 4, that's the same thing as the positive or negative square root of 45 over the square root of 4. And what's the square root of 4? It's just 2. But you've probably also already learned how to simplify non-perfect squares. And if you can see in that numerator, that is a non-perfect square. So here's how I simplify non-perfect squares. If I have the square root of 45, the biggest square that goes into 45 is 9. So that's the square root of 9 times the square root of 5. What is the square root of 9? It's 3. So the square root of 45 simplifies to 3 square roots of 5, or 3 root 5. So I'm actually going to rewrite it like that. X plus 5 over 2 equals positive and negative 3 square roots of 5 over 2. Whew! And what do we do at this point? We're going to be subtracting 5 over 2 from both sides. So let's rewrite those equations. I'm going to rewrite them right here. So when I rewrite them, I get x equals negative 5 over 2 plus and minus 3 square roots of 5 over 2. We have a common denominator, so all we need to do is combine our numerators. These are essentially not like terms, so you can't combine them. So don't. It makes it a lot easier. I'm just going to have a denominator of 2, and then it's just going to be negative 5 plus and minus 3 square roots of 5. And that is my ugly answer. But that's your answer, and that concludes your notes over solving quadratics by completing the square. I hope it was helpful.